So this is the paper tablecloth trick. You've probably heard of the tablecloth trick. That was a trick that used to be done by usually a stage magician. Would have a table full of things like cups and plates and pots and things like that. And they'd have a nice bright tablecloth. Usually it was a sort of spotted pattern or square pattern or something. And then they hold the cloth at the end and they give it a good fast yank, and everything else stays on the table, so nothing actually gets dragged off. Now I'm going to show you how that works. We're going to use slightly different materials for this. I'm going to use just a couple of sheets of paper put back to back. Now I'm using two because I want to make it a bit stronger for this particular experiment. So I actually recommend you might choose to find some thicker paper straight away. So for example, you can get brown wrapping paper, which is pretty good for this, or you could use a bit of wallpaper. But if you're going to use wallpaper, make sure it's nice and smooth. You don't want anything that's rough. Okay, it's got to be smooth here, really smooth, and you'll find out why when I do the explanation. So really smooth, like this is. Now, I don't want you using a glass, okay? Please don't use a glass. I'm using a glass now because it's quite fun. I want you to see what happens. When you do it, I would really highly recommend using something like this. A bigger one would be great, but something made of plastic. Main reason being, the first time you do this, it may not go quite to plan, and you're going to see that this may end up on you or on the floor, and it's pretty obvious that what could happen if it ends up falling off the table. So I want you to use something that's unbreakable, basically, so plastic's good. What I'm going to do is I'm going to pull the edge of the paper over the table, okay? So you need to stand at the edge of the table that you're going to use. I'm going to place the glass there first. Now I've got some water there, you'll find out what that's for in a minute. I'm going to leave that there. So what I want you to do is, first of all, push a bump into the paper. So I've got a big bump there. Hopefully you can see the ridge of it there. And the other end of the paper, which I'm holding onto very firmly, in fact, not quite firmly, I want to point that and drag it down towards my knees, okay? And that's the trick of this one. So you put a little bump in it, and when you drag it downwards towards your knees, okay? And the important thing is you go as fast as you possibly can, okay? So as fast as you can. Don't hold back on this one. So make a bump, get ready, and as fast as you possibly can, pull the paper away and see what happens. Okay, let's see what happens when I do it. And remember what I did say, it may not have worked first time. You've got to pull this pretty fast. Let's see what happens. Ready? Oh, I didn't even see that move. I don't know if you saw it move, it probably did, but I didn't actually see it. Tell you what, let's make this a bit more interesting. I like to take risks now and again. Here we have some water. I wonder if you can guess what I'm going to do with this. Yes. Now, let's try something. So remember how we did it before? So I had that about there. I want to try and make it exactly the same as it was. Remember, we're trying to do a fair test, really. Now, I can't remember exactly where I put it, but I know it was about there. Really, I should have measured it, shouldn't I? But I've put it roughly where I think it was when I first did it. I'm going to make that bump again. And let's see if I can do it exactly the same as I did before. Because now the only difference is water, isn't it? We just changed one thing. Best we can, anyway. Ready? Let's see what happens. Might get wet knees in a minute. Let's see. Now, interestingly, I saw the water move. I must confess, I didn't notice the glass move, but that's because of the way I'm here. You may have seen the glass move, actually, and it probably did. I certainly saw the water move, and if the water moved, the glass probably was moving, but my eyes just picked up the water motion there. What's going on? Well, how come the glass didn't come off and cover me in water, which you probably would have found highly amusing, I'm sure. Right, let's come back even without the water, because we really did it twice, didn't we? Well, one simple way of thinking about this is that when anything is placed on a surface and we try to move it, it resists us. It has what we call inertia. That's a proper word, inertia. It resists our moving it. And it's only when we actually give it a good push, then it actually starts moving a bit more easily once we get it going. Also, once something actually is going, it takes a bit of extra force to slow it down again. It doesn't like stopping. It wants to keep going, really. And it's only things like friction and brakes and stuff that stops things from moving anyway. Also, it doesn't like changing direction. So even if we don't want to stop it, but we want to change direction, it actually wants to keep going in a straight line. Now let's think about how some of this stuff relates to what we just did here. When I had that there, just keep the water, makes it fun, never know, might go wrong this time. When I yanked the paper away, I won't actually do it right now, but when I yanked the paper away, of course I'm the one who's holding the paper, so the paper's going to have a hard job resisting me, so the paper moves, and it moves as fast as I pull it. But the glass, it's actually stationary right now, and the inertia, the resistance to motion, means it doesn't really want to move. And because this paper's nice and smooth, it hasn't got very much friction, so it's not lumpy and bumpy enough to grip the glass. So it just slides out from under because it's resisting moving. And as long as I do it really fast, it'll only move a bit, okay? So it was moving, it was accelerating a bit, but by the time it had got any speed, the paper was dragged out from under it anyway, okay? So it's resisting moving, and that's why it didn't fall off with the paper. Of course, when I put water in, of course I started off empty, didn't I? And then I put water in, well that made it heavier, and believe it or not, that made it even less likely to move. Because the more matter there is, the more stuff there is, the more inertia it has, and it doesn't want to move even more then. So in fact, it's actually easier to do when it's heavier. It seems to be less likely to move when you do that, when you make it heavier. So I've given you a bit of a clue about other variables there. So that's what's going on. Okay, variables. Well, I've given you a clue with one of them, the weight of the object. Be careful though, of course, if you make it too heavy and you're using paper, it might be so heavy the paper will just tear around it. So whatever it is, it's got to be heavy enough that the paper won't tear it, but it can move around, okay? Now, a couple of other things I mentioned. Remember I said it's got to be really smooth. So I wonder what would happen if you used, and don't use glass for this, please. Remember I said probably use something like one of these plastic cups for this one. What about if you tried something that wasn't quite as smooth as this paper? Now remember a minute ago I said about using wallpaper. Now lots of wallpapers have sort of a texture on it, a pattern that you can actually feel with your fingers. If you use that, I wonder what that difference would make. If you do, try and find a piece of paper about the same size as the one you used at the start. Try and do everything exactly the same cup. If you're going to use water, that's great. Make sure you pull it as best you can in the same way, because then the only thing you're changing in is the paper itself. So we thought about the surface smoothness, we've thought about the weight. What about the speed at which we move it? And again, when you do the experiments with speed, please use something that's not breakable, whatever you choose to use, make not breakable, okay? Because of course, I've only shown you this, doing it pretty fast when I've done it, and I whipped it away really fast. Now, of course, an interesting question that you might be thinking of, if you're a particularly brilliant scientist, which you must be, is I wonder what would happen if we somehow change the speed. For example, supposing I didn't pull it quite as fast. Still pretty fast, but not quite as fast. Maybe something like that. I wonder if that would still work. Do you think the cup that you're using will still stay there? And what about if you do it really slow? What do you think will happen? I think somebody can probably predict without even doing it. But remember, we always test our predictions. Whatever you think the answer is, you must always test. And I'm sure you can think of a few other things to try.